So we're going to wrap up our look at electricity and magnetism by making some connections here. So we've mentioned repeatedly that up to this point, we didn't have a clear theoretical reason for electricity and magnetism to be so tightly connected. It was just something that we were seeing in the labs. So we built our formulas around what we were seeing, but we couldn't start from scratch. We couldn't sit down with just a pencil and paper and a couple ideas, write those ideas in math, and then in the end come up with a connection between electricity and magnetism and show that if you had one, the other was inevitable. Prior to relativity, that just didn't exist. But relativity changed that. Because, let's say you have a charge. It's just sitting here, happily radiating its electric field, no magnetic field because it's just sitting here. It's motionless. Well, it may be motionless to you. But if all frames of reference are equal and someone goes running by, that moving observer will see this as though it's a moving charge. And they will see a magnetic field. That's the side effect of relativity. That's what it comes down to. A magnetic field, from a relativistic perspective, isn't a separate field. That's just what the electric field looks like when it's moving. A moving electric field is a magnetic field. Period. They are two different ways to see the same thing. In order to understand why it works, we have to get into a lot more math than I can summarize here. That linear algebra course I mentioned in part 1 will get you part of the way there, but the actual mathematical tool that you need to really see the connection is a tensor. This is something that you're probably only going to see if you get into some very mathematically heavy subjects. And I mean very mathematically heavy. Engineers are known for having a whole lot of math. There's probably about 70% of engineers can graduate with engineering degrees in their specialty without ever having seen a tensor. So they don't show up too commonly, but if you go into relativity in any depth, they are absolutely essential. But anyway, this is the connection we are looking for. A magnetic field is what an electric field looks like when it's in motion.